Good afternoon, everybody. This is a live recap of the tornado outbreak on December 9, 2023. That includes the Nashville area tornado north of Nashville that went from Madison through Hendersonville, almost to the south side of Gallatin. There you can see that explosion that happened with that tornado too, basically releasing a heat source into the base of that tornado, and that ended up disrupting the thermodynamics of that tornado near ground, causing it to decondense as the temperature rose above the dew point. You could definitely see that the tornado continued at ground level. You could see that debris cloud near the ground, but it certainly looks like, at the very least, that it might have weakened that tornado at the low levels, and you have to wonder if you release a similar heat source aloft on that tornado, that maybe it could disrupt the dynamic pipe, disrupt the thermodynamics above the ground, where you get that vortex above ground, and that might change what happens near ground level. But at least video evidence, rare video evidence provided by this webcam footage that shows near the ground the disruption of the condensation and the thermodynamic gradients of that EF2 tornado near ground level. Get this fired up. Posted. And we're also going to break down the meteorological setup too. So we're going to look at the meteorological setup of this tornado event, the positively tilted trough, as we talk about, that happened with that caused this tornado event. And the reason that these positively tilted troughs go so big here across the Mid-South is that you stretch it out in the west to east direction. You take all that dry air over the Mexican plateau and then rip it east across that moisture. And those are the basics for these Dixie Alley tornado outbreaks. You get the blue sky that appears. You have the low-level winds just racing with the moisture. Supercells move into that, and that's when you get tornadoes. But you can see that after that explosion, the tornado recondensed again, reinvigorated as it moved from west to east. But let's step back to the beginning of this screen really quick. There you can see the mature tornado, and that's condensation all the way to the ground. That's cloud matter, and that happens at lower pressure more easily. So the lower pressure in the tornado, the more easily it's able to condense. And so when you get that pipe, that dynamic pipe that plants all the way to the ground, you know that there's low pressure all the way to the ground, that there's a gradient of pressure at the periphery of that. Strong winds are rotating around it as well. And watch what happens as that explosion impacts the tornado. You're releasing a heat source into it. And definitely that's an oil-filled substation, we believe, that caused that explosion. And then look at that plume of smoke that developed in the backside of the tornado. That right there also showed vertical winds inside of the tornado vortex. Not only do you have the horizontally rotating winds of the vortex, but you also get those dramatic vertical winds inside of the vortex as well. You can see the heat source lifting all the way up. And above this, above ground, is a cyclonically spinning dynamic pipe of condensation or low pressure. And who knows, if you released a longer duration heat source up in that dynamic pipe, it might be able to disrupt those wind fields near the ground level. And as that dynamic pipe descends toward the ground, you get the jet-like vortices that'll develop, those intense vertical winds too, like you saw with the Andover tornado, a lot of that debris getting lofted from the ground level and in a straight up direction. And I think if you were able to maybe disrupt the dynamic pipe just above ground and release enough heat up in that tornado, a cyclone above ground, you could probably disrupt the vortex a little bit at ground level. This one, though, was of not quite long enough duration. I step forward, and you can still see that debris cloud is at ground level. I think this is all the debris rather than condensation right near the ground level, unless that shows that there's a little bit lower pressure right near the ground that's encouraging some more condensation. And you're also releasing these cloud condensation nuclei into the dynamic pipe above it, which is going to disrupt the thermodynamics and the thermodynamics at the low levels. But at the very least, I wonder if you weakened that tornado at ground level because of the release of that heat source. But it was temporary, of short enough duration, that it didn't seem to really do a permanent number on the tornado to weaken it. And it went all the way to Hendersonville. I believe it almost went to the south loop of Gallatin, even though the recent NWS survey doesn't really show it going quite that far. But I wanted to provide a meteorological explanation for all of that, and also discuss the setup that caused 31 preliminary tornado reports across the Mid-South And you also had very long track supercell storms. The first one developed at 9 or 10 in the morning in northeastern Arkansas. And I'm going to show you what it looked like on radar too later in the video. I'm going to break down the wind shear there in Nashville when the second storm was approaching, how textbook it looked with that positively tilted trough. And this was that first storm that developed at 9 to 10 a.m. You could just tell it looked different on radar. You could tell it was going to be a long tracker, almost like that Yazoo City day in 2010 when that storm developed way early back in Louisiana. Almost like the forgotten outbreak of April 15, 2011, when that storm developed way out at like 8 in the morning in northern Louisiana and eventually produced a tornado near Clinton. This one developed in northeastern Arkansas, tracked all the way up through Clarksville, and produced the strongest tornado of the day, the EF3 tornado up near Clarksville, and that tragically took the lives of even a child up there, very sadly. And I made some posts earlier about a GoFundMe for their family to support them directly. But 6 people lost their lives from these tornadoes, and it was these in the northern edge of that instability nose that ended up becoming the long track producers. And you also had these renegades, nocturnal renegades, in the middle of the night that happened that produced some tornadoes later on. And I was headed west to east on I-40, targeting the Nashville area up here. That was my plan, just to continue east on I-40 and eventually target the nose of that instability axis. But there was another long track supercell that developed just south of Little Rock, and that traveled all the way through northern Mississippi and produced some baseball-sized hailstones there in northwestern Mississippi. And I intercepted those baseballs. That was the largest hail that I've ever seen in Dixie Alley. Big baseball-sized hail with that long track storm, and that one developed way back here near Little Rock and definitely produced some severe weather further west, just not reported. But I was going through Memphis and I saw that go tornado warn right as it hit the Mississippi River. So I dropped south to Hernando, thinking I'd pick off a tornado on a different storm and then still be able to rebound and get up to Nashville, but didn't work out that way, and it didn't produce a tornado, even though I thought I saw one very near the Faulkner, Mississippi area with that storm. But overall, the upper levels, it was a positively tilted trough, as we mentioned, and there's been a lot of discussion over recent years that you need a negatively tilted trough to barrel into the Mid-South to lead to those big tornado outbreaks. But you can see that parent vortex in this case lifting up toward the Great Lakes. Your a ski jump coming into the southern plains before, but you can see it gains this positive tilt with your trough axis tilted from southwest to northeast. But what that does is it strings out the mid and upper level flow from west to east dramatically, and it's pulling in all that warm air in the mid levels of the atmosphere from the Mexican plateau, northern Mexico, southwestern U.S., and then rips it east across the moisture. And those are the basics of instability. When you get that mid-level dry slot over the moisture, the clouds clear out, the blue sky comes out, and those supercell storms charge into the low-level jet. And even though you get a slightly veered low-level jet, the photographs are still very supportive because of these positively tilted troughs like this. The storms are able to move right off that front, and you definitely get these far-right storm motions with a positively tilted trough like this as well. So that's why you get a lot of big outbreaks with positively tilted troughs, and the reason is because of that mid-level dry slot. Look at the shape of the trough. You're pulling in all that dry air from the Mexican plateau, ripping it across the Mid-South here. All those yellows and oranges, that's the mid-level dry slot. And those are the basics of instability. And then you can see these storms starting to initiate. That's the long track supercell that I was on from just to the south of Little Rock. There's your tornado producer moving up through western Tennessee near Dresden is where it first produced the first tornado. And then near Clarksville is where it produced the EF3 tornado. And here's the damage survey. These are preliminary numbers, but winds up to 150 miles an hour. And all these were long track because they're moving so fast. You had classic shear profiles for these long track storms, and it went just to the north of Clarksville, touching down just to the west of that highway at about 1:40 p.m. And we're going to break that down on radar as well. And I want to show you where that storm first initiated too, in northeastern Arkansas, coming up here. And we're also going to look at the photographs. And here's the EF2 tornado. That explosion was out near the Madison area and crossed very close to crossing I-65. The explosion happened down there. That's when you decondensed the lower portion of that tornado. And then it continued off to the northeast, causing damage in Hendersonville. And they have it, the path terminating before that south loop of Gallatin, but I thought it went all the way up to Gallatin. Almost reminded me of that event that I missed in 2004, too, back in the day. But the National Weather Service still needs to finish a lot of the surveys and finalize many of those numbers. And I want to talk about the nose of the warm sector too with this setup. A lot of times these tornadoes happen up at the instability nose. There's your warm front. This surface map was provided by storm chaser Marcus Reynolds. And this front here was the focus for supercell development all day. And you basically had a shallow cold air mass coming in from the northwest. And one of the reasons why you didn't have more tornadoes is that supercells would develop along the front. The shallow, stable air would slide underneath them, choke them off from the low-level, unstable air, that moisture, and the low-level wind shear. But then the storm would intensify and then turn right and move off that front, move into the wind shear, and then produce some tornadoes as well. And it happened a lot more easily up near the nose of the instability. You had a more north-south oriented front up there. You had more southerly, low-level jet. You had a little bit stronger low-level wind shear, and those storms were able to move off of that front more effectively and became very long-track supercell storms as well. That's the early warm sector. Here it is later on, and the nose of that warm sector went all the way up into southern Kentucky, and that's why you got some tornadoes up there as well, including one in Bowling Green. There's the Kentucky-Tennessee border, and it looked like tornadoes were going to happen all the way down into northern Mississippi too as the low-level jet increased right near sunset. And those winds were relatively backed in northern Mississippi too, all of which influenced my decision to drop south from Memphis toward that storm. But the storm that eventually became the Nashville storm was developing just to the east of Memphis at that time, and it tracked all the way to the Nashville area. And that cloud base that I saw when I was dropping south near the Nashville area was actually the event, or near the Memphis area, actually eventually became the Nashville tornado producer. So this is a forecast sounding of way to the east out near Alabama, central Tennessee, and you've already got that stout elevated mix layer. See how the green line separates from the red line there? That shows dry air coming into the mid-levels of the atmosphere, and it's over top deep moisture. Where the green line gets closer to the red line, that's deep moisture, so you have very deep moisture depth, dry air just over top of it. And that's why these positively tilted troughs like this that bring that dry slot from northern Mexico west to east across that moisture, that's why you get such a large instability axis too. And you had a lot of these compact photographs. You had like 30 knots of bulk shear from the 0 to 1 kilometer layer. But you also had a lot of strong winds in the mid and upper troposphere, in the mid and upper atmosphere. That's able to ventilate these storms. And that's why in the late fall into the winter, you get a lot of these clean updrafts, very visible tornadoes because of the strong southwesterly winds. Kind of gave them that southwest to northeast orientation as well. Make sure I'm still live on here. Looks like I'm still live. Good heavens me. Still breaking down this event. So there's those photographs, very compact. And let's take a little bit closer look at the photographs as well. That's the elevated mix layer. But this is the VAD profile. These are taken from the Nashville radar. And you can see a lot of the strong upper level winds. You're looking down at the atmosphere here, the wind profile that's computed by radar. So here's the surface wind, due south at about 10 knots, and then your 1 kilometer wind southwest all the way up to 40 knots, greater than 40 knots in fact. And you have a lot of directional shear at the low levels. That happens a lot too with these positively tilted troughs. You get a lot of directional shear from your surface up to your 1 kilometer wind. And you also have speed shear with a 10 knot surface wind. And then you go up to like a greater than 40 knot southwesterly wind at 1 kilometer. That creates near 30 knots of a bulk shear. And you also have your veered upper level winds too. And these are strong in the middle atmosphere, and they're ventilating those updrafts. So not only is it about the low level inflow of the updraft, which basically you look at your right moving storm motion, and it was actually more like in this range when they were producing the tornadoes a little bit further right. That gave you some more favorable critical angles. But you draw a line from the tip of that storm motion vector all the way back to your low level hodograph, and the length of that vector, that's your storm relative inflow vector. The longer those vectors are, the bigger the storm's going to be. But because you have these strong winds out here in the mid and upper troposphere, it encourages these fast storm motions out near 50 knots. And that's a pretty long storm relative inflow vector. Not as long as they can get, though, when you get those monster hodographs like with December 10 and 11, 2021. You have compact hodographs here, but with compact supercell storm modes. Easily moving off that front with a positively tilted trough. They move into that low-level jet at an angle. Your right mover was probably more like that. East-northeasterly storm motion at about 50 knots. and you squeezed out a lot of low-level wind shear up near 290, 0 to 1 kilometer storm relative helicity. That's a high number up there, folks. So textbook photographs for these long track supercell storms that will produce a lot of long track tornadoes, and some of these are on the ground for greater than 40 miles. There's your compact supercell storm, and they all had that exact same orientation. Everything kind of stretched out in a southwest to northeast axis like that. There's your mesocyclone, well ventilated. All the rain and the hail taken well downstream. There's your mesocyclone intensifying. And look at that photograph. Nice and smooth, very laminar upper level winds, ventilating those updrafts effectively. We zoom into that storm a little bit closer, and they all had this textbook shape, thick reflectivity patterns. So you could tell that they were feeding off of that strong low level inflow, because you have these storms with a lot of mass in there. And you've got a hook coming around the backside. There's your mesocyclone, well ventilated updraft as well. Thank you, Team Dominator members, too, for making these possible. This was actually supposed to be a live stream for Team Dominator members. Ended up doing it for everybody anyway. But I'm going to upload a copy for members that I'm recording as well. But you can see a well ventilated updraft. Everything kind of stretched out in a southwest and northeast direction because of those strong southwest winds that will happen ahead of a positively tilted trough like this. And there's some more of those textbook photographs, and thankfully the negative contribution to that storm relative helicity there was not sufficient enough. Well, I wish that it was sufficient enough to shut down those tornadoes, but you had these strong winds aloft that forced that far right storm motion, strong mesocyclones propagating, turning right into them, and your 30 knot bulk shear vectors there in the 0 to 1 kilometer sense. So textbook wind shear for these storms. And the outbreak began in northeastern Arkansas. And look at this thing out here. Look at that storm, folks. That's northeastern Arkansas at frickin' 9 in the morning. And it already looks like it has that dog in it, that storm. It's a unique looking storm, already stretched out in the southwest and northeast because it's penetrating high up into the troposphere, feeding off those southwesterly winds. It's already got a stout mesocyclone on the southwest side that enabled this storm to turn right off of a cold front that wasn't advancing too rapidly to the southeast because of that positively tilted trough. And so this one turned right and moved off to the east, and then produced the first tornado later on in the afternoon near Dresden. And I was ripping east on I-40, barely able to catch this. I couldn't quite catch it. I was late getting out of Norman because we were getting that warehouse ready to go, and I couldn't quite catch this storm A, but I easily could have got to the Nashville storm. And when I was going through the Memphis area later on in the morning, I ended up seeing those updraft bases on the east side of Memphis as I was dropping south to Hernando to get that tornado-warned storm coming out of North Tunica. So at this same time, we'll step forward to about noon on the radar here, and then we're going to track these storms all the way to Nashville. But this storm that was going up near Little Rock is the one that I ended up getting on. Became a long tracker, and it developed all the way south of Little Rock, traveled all the way north of Mississippi, became tornado warned right near North Tunica, and dropped baseball-sized hail near Hernando right over the Interstate 55 there. And that's the largest hail that I've ever seen in Dixie Alley. And if I just would have stayed on my course of action, I saw the northern storm, though, going nuts up here. This is when it really started to go tornadic. And this is a long track storm. You can see it started to move off of the cold front here, sliding into that strong wind shear, that deep moisture, strong mesocyclone on its south side. And watch what happened as we step forward a little bit to about 1 p.m. And I think I'm on Eastern time, by the way, everybody. We're going to go back to Nashville. And we'll go when that produced the EF3 tornado a little bit further east. There's the storm continuing, and using the Nashville radar, we're scanning a little bit higher up in the storm, and you can really see that reflectivity core. That's probably big hail in there, folks, because you had very large hail with this. When you get that mid-level dry slot that's pretty close to the ground too, it brings that cold air a little bit closer to the ground and will produce, and I believe that's very close to where it produced the first tornado. And it continued, and then eventually produced its, around 1:42 Central Time, produced the EF3 just to the north of Clarksville. Let's go to 2 o'clock. We're tracking that to the east. It kind of lost its identity a little bit up here to the west of Clarksville, but still it's stretched out southwest to northeast by that strong bulk shear. But it looks like the front may have caught up to it again here, and the mesocyclone had to re-intensify, and then it pulled it back to the east of the front. Because about 40 minutes after this, it went from looking like that to this raging tornado producer to the north of Clarksville. And you can see the rear flank downdraft here surging out, big westerlies to the south of it. Your forward flank, that gradient and reflectivity is parallel to the storm motion. And you go and look at the storm relative velocity, and there it is as it's ramping up. The tornado's not on the ground yet here. It touched down just to the west of that highway. But we step forward about 10 minutes from this, and bang. That thing already crossed the highway, ripping northeast at about 50 miles an hour. Very tight gate-to-gate shear here, pulling in that horizontal spin from the north in the streamwise vorticity currents. And you can go over to the correlation coefficient, and you can clearly see debris getting lofted just after causing the EF3 damage near the highway. Very sadly, this tornado caused loss of life. 3 fatalities, I believe, and 6 total fatalities from this event. And very sadly, one of those was a child caused by this. But that storm ended up going all the way to the northeast. Eventually, to Bowling Green, it produced another tornado up there. And I would have been ripping northeast on I-40 there, probably right on this storm, which I believe it's one of these that became the Nashville storm. And you can already tell that those are healthy supercell storms. Chunky hooks right here. They have that classic shape again, stretched out from southwest to northeast. Very strong mesocyclones already on the southwest side. And usually what happens with these storms is first, you get the storm relative inflow that'll intensify. So as the mesocyclone ramps up, you get those pressure falls relatively close to the surface, and those southerly winds start ripping into the mesocyclone. And so whenever you're looking at radar, if you see this uptick in the storm relative inflow, the mesocyclone will intensify, and then eventually it gets stretched, gets more compact, and then becomes a tornado. But you can also see this storm back near Jackson had a big area of storm relative inflow into it too. Classic eventual tornado producers. And I'm back here. I think I saw the bases of a lot of these going up. I ended up dropping down to this storm that was tornado warning coming out of North Tunica. Looked pretty large, and I thought that maybe a little bit further south along the trough that we might be able to get an easier or more further right storm motion, almost a due east storm motion. And I saw that forward flank was a little bit more west to east as well. And it had a very tight mesocyclone at this time, just as it crossed the Mississippi River. And so at this time, I was positioning out near Hernando and Coldwater on the live stream. You remember that structure as it was approaching I-55 there? You line up that forward flank gust front, and it goes all the way to I-55 right there. But pretty strong mesocyclone too, big hail producer. And I saw all that storm relative inflow ramping up just ahead of that mesocyclone. And I thought, wow, this thing's got a chance to produce a tornado. And I abandoned my plan, went south of I-40, and intercepted that baseball-sized hail. But ended up, I think it produced a tornado to the north of Faulkner. And I stayed on that storm. I was here nearby Halia, just south of it. And the RFD just never really could quite get going. Almost produced out near Faulkner and eventually went near Holly Springs. But one of the issues with these storms a little bit further south too is that they were just behind the front, elevated above that shallow stable layer just behind the front a little bit. But when that mesocyclone would intensify, they'd turn a little bit to the right, cross the front into that strong wind shear, and that's when the tornado potential would develop. But further south on the front, you're getting more veered low-level flow, and they just had a little bit less of the ability to move off the front. But then we had these storms here approaching the Nashville area. That very, very favorable wind shear was in place in Nashville too. We knew it was there, but watch these storms just ramp up. We'll step forward one more hour, and I think we're on Eastern time as I'm looking at the radar here. Look at it intensify. You can tell it's going to be the lead one. A lot of times it's a lead storm when they develop kind of close together like this because it works over the atmosphere back behind it. You'll get little outflow boundaries that'll surge south, and then this storm will be less able to kind of move off the front a little bit. But you can tell that this storm is larger in size, feeding off of that very rapid storm relative inflow, turning off to the right, strong mesocyclone down just to the north of the Dixon area. You can already start to see that strong storm relative inflow start to crank into that storm. This is big inflow here, folks, right near the Dixon area. And it doesn't have a tornado on the ground yet, but this is one of the things that I always look at to try to see if that storm relative inflow is increasing and you're getting a strong mesocyclone there, low pressure near the ground, big southerly wind starting to rip into it. But eventually it'll tighten up, and that happened right at about this time, about 4:50 Central Time. It's just east of the Interstate 65 right there. That's a classic tornado signature. You've got your radar just to the southeast of it right there, and there's your tornado. You got your inflow streaming into it. You can look at a debris signature. This is near where that explosion happened, folks. And we can show you that again really quick for those that are just joining us. This is a webcam here. Let me show you that explosion. This is right when that happened. Early on, stout tornado, very mature. Condensation all the way to the ground, as you can see. As you can see there. Dynamic pipe, fully planted, folks. And you get more easy, the atmosphere can more easily condense when you have lower pressure. Basics of the Clausius-Clapeyron equation. So you introduce a heat source to this. You're increasing the temperature. Dew point probably stays the same a little bit, and you blow apart that condensation. Big condensation funnel up here visible on the webcam. You're getting power flashes as the inflow way east of the tornado is streaming in toward that lower pressure. Boom, it ignites. That's the heat source. Lifting up into the low levels of the tornado. Increasing the temperature, decreasing that condensation. And then you get that smoke plume that shows you the vertical winds near that tornado. So a tornado is not only the horizontally rotating winds, but also vertical winds, especially near the ground. When you have a dynamic pipe aloft of low pressure, when it descends toward the ground, you get these vertical jet-like vortices that develop beneath it, like the Andover tornado, lofting debris, and that shows you that smoke plume lifting up to it with strong vertical velocities near ground level. But it decondensed the tornado, but the tornado's continuing because by definition a tornado has that damaging wind near the ground, and you can see that debris cloud right near ground level there. That's the debris cloud, folks, that's happening. But it decondensed this area above it as that heat source lifted up into the tornado. Definitely disrupted the thermodynamics of that tornado, disrupted the gradients. So you ask, can you blow up a tornado? And I think you might be able to. Especially if you can get that heat source lasting long enough and get it aloft up here in that dynamic pipe, aloft in the tornado. Disrupt the condensation up there. You'd have to get some serious permits though to cause a heat source like that. You would probably be getting all kinds of issues up there. So don't try this at home, folks, but let the professionals do it. And I probably couldn't get the permits myself to do that, but I do think that if you get a heat source aloft up in the tornado and disrupt the dynamic pipe for a long enough period of time, you'd probably disrupt the wind field near ground level too. Maybe Team Dominator needs to shift our focus from videotaping these tornadoes and deploying sensors around them to trying to disrupt the tornado completely. But we were just looking at the radar right at about the time of this, as we were looking at that webcam footage right at that explosion right there, folks. And we'll go back really quick to the radar, and that's where it was. 450 or so. That's when your preliminarily rated EF2 tornado was touching the ground. And we can go to the TDS debris signature, and this thing was estimated based on statistics and how high the debris is getting lofted into the tornado. There you can see your debris ball. Pretty classic debris ball right there. So close to your radar, just to the southeast of it. That was given a preliminary it was estimated at an EF3 wind field, causing that debris lofting over 20,000 feet. Rotational, or your winds estimated at about 150 miles an hour, and that was confirmed by your damage survey too. But there's your debris ball, your TDS. You go over from the TDS to your couplet, and there it is, folks, right there with this tornado. Classic reflectivity pattern with your strong southwesterly winds ventilating the updraft. Big mesocyclone down here, hydrometeors getting taken way downstream by this. But the mesocyclone's so strong that it's able to turn so hard to the right, just a couple ticks north of due east. And that was also key to getting those larger critical angles out in Dixie Alley. So big mesocyclone there. You can see your RFD gust front surging off to the south of it. Mesocyclone pulling in that inflow. I was wondering if maybe some of these showers out in front of it might disrupt this event. We saw this happen yesterday too in the Carolina Piedmont. It disrupted yesterday's event, but the bulk shear was strong enough with that positively tilted trough for this one that it was able to just drill right through. And you can see this storm back behind it trying to get going as well. But more outflow on that one. So this continued. It went through Hendersonville. EF2 damage, but that's preliminary. It could even be a little bit higher than that when it's all said and done. Look at that, just rocketing off to the northeast, and then it started to weaken a little bit here, even though the debris was still suspended in the air. And it went all the way to that south loop around Gallatin. But looks like, according to the damage survey, that it began to lift by that time, even though your reflectivity looks textbook. Whenever you get that cyclonically curved reflectivity gradient with that storm, you know that it means business. And again, you could just, those photographs, the strong mid and upper level winds, pulling that wind downstream, tilting your storm southwest to northeast. Textbook tilt on it too, southwest to northeast. There's your big mesocyclone on the south side of it. Wow. Very sad, the loss of life, the damage caused by this event. Wanted to show you quick a breakdown of the storm structure as well, now that I have everybody on here too. Thanks everybody for tuning in. Thanks for dominating that like button. Welcome new Team Dominator members too for making all of this possible. And I have about a 7-minute video. But first I want to show you the hail. And then I'll show you exactly what the largest hail that I've ever seen in Dixie, folks. It's about a 4-minute video. And I was going south to north, and suddenly I see these giant white chunks of ice coming down from the sky. And I knew that it was slinging hail way west to east, well, due east of the updraft. And I look and I saw this cluster of baseball-sized hail right on the side of the road, little spikes sticking out of them. And I was like, dang, I thought to myself, that's like something that you would normally see during the high plains. And that was that storm that was just to the south of the Memphis area. And again, it's those positively tilted troughs, everybody, that you got to watch out for. And again, here's what I mean by that positively tilted trough. You basically had that main vortex up here that lifted up kind of toward the Great Lakes. And this trough axis ended up kind of getting stretched out from the southwest to northeast when it ejected. That was kind of the trough axis. And it stretched out that upper level flow from southwest to northeast. And it grabbed all that dry air from the northern Mexico, from the Mexican plateau, and then just ripped it across the mid-south. And when I was out there chasing this thing, you could see the blue sky. That's always what happens when you chase these events out in Dixie Alley. You see the blue sky that surrounds the storms, and that's all the elevated mix layer out there. And that's because of that mid-level dry air that it gets grabbed down here in the Mexican plateau and ripped off to the northeast. You can see that storm developing south of Little Rock. I intercepted that storm. I was on these storms that became the tornado producers. But you can clearly see that elevated mix layer just surging off to the east. So I have that hail video pulled up. It's the largest hail that I've ever seen in Dixie Alley. So let me show you this really quick. And also the structure.
There's the hook! There's the hook! Wall cloud off to the right! That there's the wall cloud! Hardcore wall cloud off to the right!
Well, so I went south to north there on I-55, and that was when I ran into that big hail, baseball-sized hail out there. And you knew that it meant business, but it also meant that that storm was probably a little bit elevated above a shallow stable layer. So I was kind of struggling to get off that frontal boundary a little bit. But that's some of the largest hail that I've ever seen in Dixie Alley. I kept chasing the storm off to the east too. Look at the people just pulling over on the side of the road, panicking out there.
Set tags right in front of me. Big hail coming down still.
You could definitely see that condensation. Look at the low-level condensation streaming from east to west. Notice how that's happening as well. And that's how you know that the circulation's still probably a little bit off to my west, waiting for it to come through the trees. But I was still watching that cloud matter move from east to west, folks. And I'm going north, so you know that that circulation is likely just to the west right here. A very large hail intercepted out there.
Wow.
See the wall cloud off to my northeast at this time. It was actually to my due east, but this is the wall cloud here with that storm. So if it had a little bit better shear, it probably would have produced. It's just a little bit ahead of that large hail as well. Very large hail producing storm. Eventually this thing went all the way to the Corinth area, just kept ripping from west to east through Corinth, eventually making it all the way into Tennessee.
Look at that motion. That is some rapid motion right there. It's trying. That is definitely trying right there. I might already be down. Look at it, just left of the tree.
Look at it. Wall cloud over here.
Rapidly
Look at due east
rotating
at the
wall
wall
cloud.
cloud now.
Near Holly Springs.
So this is just after I went through the hail and I'm looking due east at the wall cloud from I-55. You can see the northerlies on the back side of it too. Mesocyclone moving off to the east here. Pretty classic. Yeah, April 3rd and 4th, 1974 was produced by kind of more of a neutral tilt trough. So was the super outbreak of April 27, 2011. Palm Sunday was positive tilt. There was also that trough in like April 2006 that was positive tilt. I think 2020 was a positive tilt. I had the photograph pulled up too earlier in my discussion here. But yeah, continuing off to the north. Thought I had it in this video. You know what I didn't? That was all the hail, so I want to show you the structure too on this thing. Here it comes. Go back to the explosion again. Decondense the base of the tornado. Yeah, I agree. Not a power flash. That was an explosion. And then you had that pipe right there showing you the vertical winds inside of the tornado. This is what we want to better understand here at Team Dominator by shooting our miniaturized sensors into the tornado. They can ride the tornadic winds, those sensors. So when we launched into that tornado in 2019, it went all the way up to like 30,000 feet. And what we want to do is put a bunch of sensors into the base of the tornado like this so that we can measure the thermodynamic gradients in the base of the tornado, so that we can actually measure these vertical winds inside of the tornado too. Because what's really interesting and also naturally what's the most impactful are the winds and the thermodynamics right near the ground level. So what happens with a tornado is you get the dynamic pipe that gets a little bit closer to the ground. It has low pressure on it. And then as it gets closer to the ground, it excites these jet-like vortices underneath it, strong vertical winds. Vertical winds that will race into it. So I think that if you could disrupt the dynamic pipe above the ground with a strong enough heat source, you might even be able to disrupt or even weaken some of the winds at ground level in something like this. But you can see that the debris is still in progress at the base of the tornado, so it didn't weaken the tornado completely, but it definitely did decondense the tornado up above the ground. Yeah, that explosion was a substation that was actually filled with gas, I believe, or oil. And so probably a bunch of power flashes that happened in there. The double-barreled high, it was trying, was maybe not a negative, but indirectly a negative, because it encouraged the trough to go positively tilted because it sheared over top that trough just to the east of it. So I would say it was a negative in terms of the fact that it kind of made it happen. Definitely. So. But we were doing our live update during this. We had Connor on the ground out there, we had some other storm chasers in the field. Got to get Copper back out there too.
It's rotating. Right.
So here it is. This is the video of that large hail producer approaching when it was near the Mississippi River, just east of the Mississippi River. And I was watching that area of darkness. And I already saw a softball there, but I was watching that zone right there, right near the notch. I thought it might have even produced a brief tornado there. But that's where I was watching with that tornado right there. I saw that dark area, that cloud matter, so I was thinking that that could have been the tornado. But it definitely had a little bit of trouble staying off the front. The front just kind of would undercut that storm a little bit, and that's probably what contributed to its large hail size. But it definitely was trying to cycle as well, but very rare. I mean, a lot of times during late fall into winter you'll see that, but look at these softballs hitting the ground, baseballs.
Huge hail! Got very large hail coming down, almost to the size of tennis balls. Huge Dixie Alley hail out here. Formerly tornado warned storm. Cars shutting down here on the road. These are baseball hailstones, folks. That's very rare here in Dixie Alley.
But you can see how impactful the hail is out there too. This is like something that you see in the high plains, just disrupting traffic, people getting their windows blown out. Somehow all those big hailstones missed my car. Not a single one hit my windshield, which is an absolute miracle out there. But this is like something that you'd see in the Texas Panhandle. You see the emergency lights. And a lot of this was because the storm was just a little bit elevated too. But this storm showed mothership structure all the way through northern Mississippi, eventually up into central Tennessee. It's all these photographs that matter, the kinematics of these storms, everybody. And again, it was crazy that storm developed in northeast Arkansas, tracked all the way across northeastern Arkansas, and some of these tracked all the way to West Virginia even. Oh, look at that storm. That's the one just east of Hendersonville there. This portion of the line also started to convect, and these didn't produce, so the wind shear was definitely more favorable on that nose of the instability further north. But then later on in the evening, you started to get some renegades further south too. This one down near Jackson became a tornado producer. Southeast of Jackson, Mississippi. There's Jackson. Classic renegade down near McGee. And this one ended up producing some tornadoes too. So you still kind of had that bimodal distribution to it. Right here, you've got a healthy but a broad mesocyclone, which tightens up as you go a little bit later on in the day. Let's go to 6 o'clock. There it was a little tighter. That looks like it's probably capable of producing a tornado a little bit more mature of a couplet. You can definitely tell that it's trying to organize. But yeah, you even had tornadoes over southeastern Mississippi, and then it weakened here to the north of Quitman. So quite an outbreak, and definitely that explosion was just remarkable, folks. So decondensed the base of the tornado, disrupted the thermodynamic gradients, didn't completely dissipate the tornado as it's still on the ground down there, but definitely a tragic day though too for people across Tennessee, from out near Clarksville down on the north side of Nashville as well. And just before the holiday season, on the 2-year anniversary too of the December 10 and 11 outbreak. So thank you everybody for tuning in. Thank you new Team Dominator members. Thanks everybody for tuning in, and definitely give our thoughts and prayers to those impacted by these storms and these tornadoes. Thank you everybody for tuning in, and never stop chasing.